Hi, my students. Right, having been introduced to trigonometry, the definition and the ratios as such, I've got to hope that you have mastered that. And if you have not, can you please master that one out? It's very simple. Take note of the name itself. So, ka, you see this one? To, wa. As a teacher, I'm able to write this one down. Why I know what it means by the three letters, the second set of three letters, and the last three letters. That's more important. The link down here, for those maybe you are just joining us, can you revisit the previous videos? But it's just simple topic as such. Right, so that today we take ourselves into the working of problems and see how these ratios are being used. Right, without wasting time, let's get into business. Is problem solving. Right, so here I'll not be much interested in the number of problems we are going to solve. We may not manage to solve all those problems, but I'll give you the guides on how best you can choose the ratio here, because you'll be given some problems here all about the right angle triangles. So it'd be like now, in this case, if I'm to work out, the teachers told us we have to use the ratios, the three ratios. How do I pick a ratio and how do I use it? Right. I'll explain this one better when you have the problems as such. Like here, for example, we have got two problems here. The first one talks about the triangle, the second one is about the rectangle, and it can be any application. Also in physics and the like other areas of concern, problems comes when you may need to use the trigonometric functions. Right, like say for example here we have a triangle which we are given to say it's a triangle ABC, in which AB is 7 centimeters, angle B is 90 degrees, and angle C is 25. We are asked to find the value of the length of BC. Definitely, this is right angle triangle. So it's the time when you think about the trick. In case that first method you learned in JCE about the Pythagoras theorem, because that's also works when you are to figure out problems about the right angle triangle, you can use Pythagoras theorem. By the time that one is weak, so now you can jump into trigonometry. So here, let's first of all draw the triangle before I give you the guides on how best you can choose the ratio. Right. With the problem when it comes, it's better that first of all you summarize it into a diagram as such. And then we figure the diagram, it gives the direction of what you can do. Triangle ABC, you draw the sketch. Always want to have your sketch because we are not constructing. So here I've got triangle ABCD like this one here. I've drawn is a triangle. They say AB is 7 centimeters, angle B is 90. So I'll first of all have 90 degrees, set it somewhere where I've already drawn up the symbol of that kind. So this is my B, it's 90 degrees. And then the other letters, I'll just write them out. Say this is A, B. So I take this one as 7. And then the last vertex here will be described by letter C as such. So here we mean C, angle C. Here there's a vertex, so the angle within it should be 25 degrees. Right, so it means everything about what is given in the diagram here has been interpreted in the, has been given in the question here, has been interpreted into the diagram like such. So we have here triangle ABC, in which AB can see 7 centimeters and BC is not given, but this angle is 25 where this one is 90. What are we required to do? Find the value of BC. So we are there going to work the value of BC. Right, but bear in mind, we have ratios. And definitely here, we need to do the ratios. You can consider about Pythagoras sometimes to find the value of BC, but Pythagoras theorem needs you to have at least two sides given. Here we all have only one. I didn't mean to add the value of this BC very well, you would have opted to use the word Pythagoras theorem. So in such instances, as a student, please, you need always to consider both ways, but now when one shows weakness, you analyze it out, then jump into the other one. So obviously here, we have to go into the trigonometric ratios. What do we have? We have got sine, which we know for sure is coming from the opposite over hypotenuse. We also learned something about the cos, which is coming from what? You talk of the adjacent over hypotenuse. And then finally, what do you have? We have got a tan, which you know you can find it when you divide it, that's a talk of the opposite over adjacent. Talk of the tan, cosine, sine of a particular angle. Right, so in this case, as you can see, the theta we had in the previous discussion here is now represented by 25 degrees. This is an acute angle, it's 90 degrees. Right, so we say you can use the trigonometry. So it'd be like now, how can I use the trigonometric ratios to work out the BC? Right, so by what we discuss in this case, you'll be able to know now by a given angle the name of the sides, what you have there. So if we're having this angle here given as 25 degrees, if I consider this 25 degrees, then definitely you know that this side 7 centimeters is what? Opposite side. So here the opposite side, if we consider the 25, is 7. Unless if we have this one, you can find it means the opposite side will be BC. And this side here, the one you'd like to find, BC, you can be able to write that this is the adjacent side. So now, if you'd like to use the ratios in this case, you should be in the position, first of all, to get to know about the sides you are having on the side, on the triangle. Yes, you have got 3 sides, but now to depict the ratio here, you'd find that each ratio talks of 2, a pair of sides. Like this one talks of opposite and hypotenuse. This one talks of adjacent, hypotenuse. This one talks of opposite and adjacent. But the triangle has got 3 sides. So for you to choose the ratio, you have to set out, first of all, ask yourself, which side are you given already in the question? So you find that here you are given one side as 7 centimeters. We get to know the name of that side. What is the name of side you are given? Please, I insist here that you guys have to understand this one. Get to know about the name of the side whose value is given. Like here, that will be given this side AB as 7 centimeters. What the name of this side in relation to the particular angle, you'd be able to tell that this side is the opposite side. So put that on the side. So according to this one, I have a side which is opposite that is given. Secondly, get to know the name of the side that you are asked to find its value. Like the question here is asking you to find the length of what? BC. So take note, this side is asking me to find is a BC. What is the name of this side? So you'll be able to learn that this side is the adjacent side to that angle. So here it'd be like the story is about the opposite and the adjacent side. So the 2 sides which are there by what I've described with you here should give you at least a guide as to which ratio are you going to choose from that. So here, just go for the 2, just go for a ratio which has got the opposite and the adjacent side, because these are the ones we have here. Side you are finding is adjacent side, so take note of that. A side whose side is given is the opposite side. So it means opposite and the adjacent are the guides that will determine the particular ratio that will pick from there. So obviously, if I can align the sine, cosine, and tangent, the ratio that is worthy to be used in order to find BC is the tan ratio. Had it been I was given the side AC, then definitely I would have talked of opposite, hypotenuse and the adjacent. So there again, it means I would have gone for a cosine. So please, name of the side given and the side you'd like to find will be able to give you the story. So you see how simple this one is. Right, so how do I write? Presentation matters most again. So this is the way it goes. Solution. I would like to find the value of BC. I will take note of the ratios. So here it'd be like that time we're talking of tan theta is something. Now we're not write tan theta, but we're going to write what? Tan over 25 degrees instead of tan theta. How do you find the tan ratio? You talk of the what? Opposite over what? Adjacent. So in this case, your opposite side already is given here as 7. So this one will be over what? Over BC as such. Look at that. Tan 25 degrees is equal to 7 over BC. Right. So what is it that I'm going to work? So what I've had there is just like the what? It's just like an equation. So more, if you have written that relationship between the angles and the sides of this triangle like that, there's more like now, go ahead and solve the problem. Find the value of BC. So by what we did about the algebraic fractions there, you know for sure if you are solving out a problem, you like to find the unknown. Definitely, the first thing you do there, how to get rid of the fraction. So you can do that by multiplying both sides by the denominator. In this case, it's BC. So here multiplied by BC, here again multiplied by what? BC, to get rid of the fraction. So here it means BC times this one, it will be BC tan of 25 degrees, which equal to this and this one, they cancel. Here I'll mean with what? A 7. Right. My interest is BC. I don't own the tan of 25. So what do? I have to get rid of the tan of 25. How can I get rid of that? It's only by division. So you divide again by tan of 25 degrees. But not to violate the rules of the equation. The measure you do on one side, I have to do the same on the other. So it means here, I should also apply the same mechanism. Have to divide by what? Tan of 25 degrees. So tan of 25 cancels for another tan of 25. That is 1. So what do we have then? We have this situation here that say here will remain with BC, and I write here as BC equal to what? 7 over tan of 25. So tan of 25, here you are allowed to use the what? A calculator. Go on the calculator and find that ratio that is describing the tan of 25. So without wasting much of our time, we can be able to find that the tan of 25 is the value that is 0.4663. So it divided by 0.4663. So when I divide 7 by 4663, what you get there, I think you're also doing the same. You have the calculator there, you'll be able to see that the value you get there is 15.012. To tell us the story that say if you correct this one maybe to nearest whole number, you'll be able to figure out that say the value for BC is simply equal to 15 centimeters. 2, that is the nearest whole number. That's it. So look at that. Very simple. But what is more important here? To know the ratio. If you are good at knowing the ratio, the rest of the story is a matter of just solving an equation as such. So this is the way we can solve this problem here. So I ask you to go through again this problem, though you know it, but a matter of mastery. You need to master this one, you have to master the concept. You will not come, we solve this question in exam, but what will come there, you need to apply this mechanism. Please go through this one out. Right, so we're done with that. Let's go to the second problem now. This other one, also simple. It's not the triangle now that is given direct. So it's just like now you should expect that sometimes you'll be given a certain figure on which you need to drive out the triangle or set form the triangles which are right out as such. So here we are having that is a rectangle, which is 5 centimeters by 6 centimeters. We are asked to find the angle that is made between the diagonal and the longer side. So what is here? First of all, you need again to draw the sketch of a rectangle. As here, previously, we drew the sketch of the triangle, of the triangle. So a rectangle, we know this is a 4-sided polygon, right? With all angles inside being right angled. So this is my sketch. Right? Goes something like this. You have your sketch of a rectangle. This one we have here. Indicate the right angles and the vertices. This one. You are free to describe the triangle by any of the 4 letters of your choice in that order. So I'd prefer to define this rectangle by X, Y, Z, Q. Not X, Y, Z, Q. So my order should be X, Y, Z. So you say now this rectangle is 5 centimeters by 6 centimeters. It means the 2 sides here are defined, one being as width, the other one is the length. So the longest side is defined as the length. Let's consider this one as 6 and this other one as 5 centimeters, it's the shorter side. Right. So this is a rectangle. Our question is angle made between the diagonal and the longer side. So what do we have here? What we do is first, let's draw the sketch of a diagonal. So a diagonal is just that side, is just a side that, or just a line that cuts the rectangle into two equal halves, and it connects two opposite vertices of the rectangle itself. Either this and this one, the line along which connecting z, x, and z, that is the diagonal, or a, q, and y, that is another diagonal. So just draw it and see what we have at the end. So what we have here is something like this. I'll join x and y to form what we call the diagonal. So xy is a diagonal. So angle made between the diagonal and the longest side. So this is the shorter side of the rectangle, and the same like that one. When I talk of this one, I talk of that one. And this is the longer side of the rectangle. It's the same like that one. So I talk any one of them. Right. So like in this case, let us now find the angle. So in short, let us just find the angle made between this and this one can be represented by this one. Or not, you don't choose this side as the longer side. Since this is the same like that, then you can have an angle like that one. It means this is 5, this one is also 5. If this is 6, that is also what? 6. So this choice is yours. Right. So without wasting time and also congesting the diagram, can we just concentrate on one area of concern because it means the same. So here we are required to work out the angle YQZ. Right. So now, how do I go about three ratios as such? So my system on how to use the trigonometric ratios, the choice will remain almost the same. Like as to how do I work out for the angles, more similar as to how you were working out on the side. How do you choose the ratios? So in this case, if you are going to find the angle in a triangle, like the moment we have done here, the moment we have drawn YQ as the diagonal, definitely here we have yielded up a right angle triangle, which you can call it as triangle YZQ. And obviously, in this case, you are there to use the what? Trigonometric ratios. Right, you can't use Pythagoras to find the angle that is not on. So now you are there in triangle YZQ. You write it, say, in triangle YZQ. What do I have? You'll be able to see that this side which you are given here, you look at the side which now given. I'm given this side. What is the name of this side? Still more describe the side. You find that this side, in relation to the angle that you are going to find. Take my words. I want to choose the ratio here. We have got three ratios in the Sokatoa. Which one is worth to be used in working out the problem about angles? So if I find the angle, the technique you use to choose the ratio is what I'm going to describe here. First, take note of the sides which you have. I have got side YZ of that triangle is given as 5. Another side is given as 6. So just like two sides which are given, you have to take note of them. What are their names? In relation to what we have just discussed about right angle triangle. So you find that this side here, in relation to the angle which I would like to find here, the theta. You can describe this on the theta, though you won't have a description there. You find that this is the opposite side. So 5 is the what? Opposite side. And if you look at the 6 here, 6 is what? You find that 6 is the what? Adjacent side. You just have to go by that. On that here you consider that we're talking about the same, about the situation area, but now the thing is the tips. 5 given here is opposite, 6 given here is adjacent. It can happen that 5 is given there is, it can happen that maybe the side to be given is the hypotenuse. If you're given all the sides there, just choose any two sides and take note of their what? Sides in terms of names. So here our 5 is opposite, 6 is adjacent. So in this case, you just choose out of that, say which side talks about the opposite and adjacent at the same time. So in this case, you find that it is tan again. It's the one that talks about the ratio of the opposite to adjacent. There's none apart from the tangent that considers the two sides at the same time. So obviously, it means in this case, the ratio to be used to work out that angle is the what? You talk of the tan ratio. So you don't have to hesitate there. The moment you have written that one, say in triangle YZQ, you have selected the triangle there. Like, say, tan of this angle here. That's a talk of the angle YQZ. That one is equal to opposite divided by hypotenuse. Sorry, that's the adjacent. Thus now we talk of the, that's a talk of 5/6. Look at that. Please follow me what I'm trying to say here. So what you have here, what do? Divide 5 by 6 and correct your value, at least correct 4 decimal places. Because there are also table values which you can be able to use it, that are all corrected in that. So instead from, try at least to correct the value of that ratio into 4 decimal places. We prefer you to present this ratio of the opposite to adjacent in the decimal fraction. So if you can use the calculator where you are, you'll be able to realize that, say, the ratio of the 5 to 6 is a 0.8333. The 3 just goes like that, so you call that 4 decimal places comes like that. Right, so here we take that, say, tan, that is of angle YQZ is equal to 0.8333. Right, so it means what it is here is just like as we took, we said earlier, we talked of the ratio in relation to the particular angle. It means whatever we see here, the angle for the for YQZ is contained within here. Right, so it's just like this is just like the reversal part of this angle. As such, if you'd like now to find that angle now out of this, you just have to take the tan inverse of this one here. The inverse of this one, it will be the angle of which. But the angle, tan of that angle will give you this one. Now the inverse of which will give you the angle. So as such, you find the angle, we'll write here a symbol of the tan inverse. Instead of now the inverse, that's more like the opposite of this. You write it with the symbol here, raised to, you just say tan raised to the power -1. That talks of the tan inverse. Of what? 0.8333. So if you go to the calculator and press tan inverse, the first thing you do, there's a symbol there, talk of the second function on the calculator sheet. You press that one, then press the button, which is the tan. This symbol will come out, then you enter 0.8333. You'll be able to see that and press equal to. The value will come out of that. You'll be able to see you're getting 39. That is what? 8. Right, there's some values here. But rather, for the angles, we usually correct them to 1 decimal place. Right. So if you don't mind about the decimal fraction, you may be able to express that angle to the nearest what? Or number. And that will give you what? 40 degrees. I'd like here to say to the nearest whole degree. That's what we liked. Just that. Right, so at least with the 2 examples here, I've given a guide on how best you can use the ratios on how to calculate this side. Mark my guidelines on how to choose the ratio. Secondly, we have also discussed on how you can use the trigonometric ratios to work out the what? The angles themselves. That are also the guidelines I gave you. So you should always look at the guidelines. Do not memorize the answers. But what has he said? How has he chosen the tan? How has he chosen the tan again? Not the sign. I've not chosen the sign here. I've still not gone for the same tan. By the guides I gave you, my description of this always guide me to choose the tan. It's by that. So it's not just a matter of saying in a ratio, the guides. 2 sides, what are the names? Opposite and adjacent. Then it means opposite and adjacent there about time. I didn't was the opposite and maybe talk of the hypotenuse. I would have gone for the side. You see? But how to present my work? This is the way we do. It goes like that until at the end like this. Right. So that's it that we have here. Right. So thank you very much again, because I have got that hope that now you have it that say also in the brain that say, you know what trigonometry is. you know what trig 1 is varying us to, and then you know the ratios aside, and now by this time you also know how to use the ratios on how to wake up the problem. In the next video, I will still more come with you for 2 more problems before we go into the other category of discussion about the trigonometric ratios, right? So that you should be really sure on how best we can also choose other ratios to work out the problems attached to the trigonometry. Then is when I'm going to give you an exercise just to try them out. But first, I want you to be really conversant about what is in the trigonometric issues. Right. Thank you very much for being together. And I hope that in the next discussion, we'll be together again. Please, let's do so. Thank you.